Well, good morning, everyone, and thanks for logging on here to the BAM Chase Facebook page or bamchase.net or wherever you may see this video from this morning. It's about 10:30 on January 30th, 2014. And I want to take a minute here. First off, what you're seeing is models that were in advance of Hurricane Sandy or Tropical Storm Sandy or Snowstorm Sandy or whatever the proper name for it may be, Superstorm Sandy, whatever. So I want to take a minute before I get into this data and explain to everybody what BAM Chase is all about and what it is that we do. We've been in business now for over 3 years, together for over 3 years, and been posting forecast guidance data to our Facebook page for many years. And I have a few people that even in the beginning were not a fan of what I was doing, and now are some of my best friends. What I do, guys, is I take computer models and I post them to Facebook, to Twitter, to our website, because they're guidance, and these models are generated for that. They are made in order for us to make a forecast. So you can call people model huggers or model digesters or model copying or whatever it is you want to call them, but at the bottom line is no matter if you're a National Weather Service meteorologist in charge of the entire office, or if you're a Storm Prediction Center meteorologist, or you're working out of the Weather Prediction Center, you have to look at weather models to make a forecast. Okay, the best weather forecasters, in my opinion, are weather forecasters who can make forecasts based off of experience, common sense, and sometimes throw data to the side. Okay, we have data that will go out some as far as guys. Look at these hours here. As far as this stuff will go out, you can't even see it goes out beyond 288 hours. It goes out beyond 360 hours. We have weather models that will predict seasons. The CFS version 2, one of the most largely controversial models there is. One run it's going to show the country in the freezer. The next run it's going to show the country in a major heat wave. And yet, there are still going to be people who are preaching these models as gospel. And here's the thing: is these are all guidance. So, very first thing here is, you guys remember the post I made the other day about the Canadian model, right? About the 30-inch snowfall Canadian model. And guys, the thing is here's the thing: is it's guidance. All right, and any of you guys that know me should know that that's how I do things. And I post guidance because it doesn't mean 30 inches of snow is going to fall. And if you were a subscriber of mine and watched my videos, you would know that. You would know, because we make that very clear to you. Okay, here is, let me show you the post that was referred to around the entire Facebook community. The Canadian model dumping 30 inches of snow. Okay, that's a piece of guidance. Okay, it's out 168 hours. Now, if it were not okay to post this guidance, or not okay to discuss this guidance, and it should be restricted or blah 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 or whatever, why is it even possible for the computer to go out that far? Okay, it doesn't make sense. It's just a piece of guidance, and by no means was it ever discussed as an official forecast. So, guys, My thing is here is that we rely on these things. We look at overall teleconnections. We're going to get into some terminology here. I'm going to tell you a little bit about how I do things. So just pay close attention. What you're looking at is an image of Hurricane Sandy, or the forecast image of Hurricane Sandy, and you're looking at a 174-hour image here, which is basically about 7 days out. Okay. From the time that the model predicted this, about 7.5 days. Okay, so you see the European model here, basically saying, okay, here comes this storm, going to come in right off New Jersey and New York area here and plow us. And here's the model down here showing the 850 millibar temperatures as well. Okay, big question with this storm was, back when I was analyzing this, is, could there be a bunch of snow? Could there be just a big superstorm of all different kinds of problems? Yes, there could be. Go over here and we look at the GFS model. There's nothing there. There was no storm. So That's a reason beyond 5 days, Hurricane Sandy, that there was no mention of it. You know, there was this big storm coming, but it was going to go out to sea. It wasn't going to hit the coast. Big model confusion. Wouldn't worry about it yet. Wouldn't fret yet. So you're telling me that because one model says it isn't going to happen and the other one says it is, you're going to tell 60 million people not to worry about it. And it turns out to be the most costly destructive storm in the history of the United States. It's just, I mean, just absolutely annihilated the northeastern portion of the country. And the forecast model guidance, 7.5 to 8 days out, nailed it. It did. It's the facts. It doesn't matter what anyone's opinion of it is. It's a fact. And this is a reason. This is one of my explanations. When you have a storm that is deepening and exploding, going under a bombogenesis, it's deepening into a major storm system, it's naturally going to go north and even a little bit west. It's going to pull poleward, okay? It's the vorticity in the system, the deepening of the system. And you're getting into synoptic meteorology and all this stuff. You're getting into a lot of technical terminology. But the bottom line is when a storm deepens, it's going poleward. It's going north, okay, and west. So if this storm right here is deepening and going north and west because it's deepening, why would it go to sea? Why would it go out to sea? Why would it go out there if something this powerful is coming? And then if it does go to sea, how is it going to go to sea? This massive block in place, as it starts to turn north, is literally going to shove this storm back in off the coast. One of many reasons as to why this happened. But this is a model guidance. This is as 8 days out. Okay. Another thing I would like to show you is the potential storm last year, the blizzard last year. Some call it a blizzard, some don't. The storm after Christmas. This is 108 hours out off the GFS and the European. This is one of many examples that I have saved in the computer here. Okay, what you're looking at is an operational run, the deterministic run that's used on a daily basis of the ECMWF, the European forecast model. You're looking at surface pressure, precipitation, and thicknesses. Okay, thicknesses are the thicker the air usually. All right, the warmer the air can become. The less thick the air, there's less room for things to become warmer, if you will. Okay, the ensemble forecast. We look at ensemble. Okay, the European model just so happens it has 51 different ensemble members. The GFS and the Canadian just so happens they have 21 different ensemble members. So you have almost twice the computing power here. We do have twice the computing power of the European. 51 different engines, different variation, different initializing conditions, changing things just a little bit to see how things are going to differ. Okay, we're pegging this storm. With 6-7 lines of pressure through the state of Indiana, one can make a case at 40 to 50 mile per hour wind gusts. Okay, so when you have your operational run and your ensemble run of both major global models picking up on a storm, of course we're going to mention it. Why wouldn't we? That's what we do, and that's how we have become to where we are now. Okay, is we don't just make a forecast based off of one single run and not talk about the others. If you were a subscriber and you knew what we talked about in our videos, I'm not trying to get you to subscribe. I don't need you to subscribe. It's not a big deal to me. We have plenty of people who support us and work with us, and that's fine. But here's the thing. If you're going to post a model run and then not talk about the other model runs, that's a problem. But if we want to discuss, it's for fun. We like to post these things and say, man, look at this. This would be cool. A lot of snow. It would be fun. People like snow. Everyone likes snow. But unfortunately, it brings out the worst in people. This is the European model 174 hours out prior to the Henryville, Indiana, the Henryville tornado outbreak that killed, I believe it was 28 people throughout the lower Ohio Valley here. A major tornado outbreak. This model pegged this nearly 10 days out. Pegged the outbreak. A strong 992 millibar low. I believe it even got to sub 990, 989 millibar low perhaps. Strong negative tilt trough. A big shot of cold air coming in behind it. A big, very strong low-level jet system. Winds at 3,000 to 5,000 feet at 70 to 80 knots, pumping in a lot of moisture. It causes conditions in battles and air masses, causes ripe conditions for tornado outbreaks. Okay, the day after the Henryville tornado, there was 1 inch of snow on the ground in Henryville. And look at this. When you get 534 and 528 thicknesses moving in on a big storm like that, you're going to get snow. It's going to be very cold, especially with something pulling in this much moisture. The negative tilt nature of the trough, the southeast to northwest orientation of the trough, will allow for abundance amount of moisture to be pulled in and wrapped around the system, wrapped in around the backside, bringing the potential for snow. Okay, so those are just a couple of different scenarios of longer range model runs that have literally nailed forecasts. Okay. Now listen, when we talk about ensembles, for example, this is the 0Z, which is the 7 p.m. evening run of the European forecast model, both the ensemble mean and the operational forecast model. The green line is climatology. That's where we're supposed to be for that time of year. So these are temperatures at 850 millibars, roughly 4 to 5,000 feet, okay? Anything below the zero here, you see this zero right here? Any of the squiggly little lines below the zero would indicate that any type of precipitation that were to fall would be in the form of some type of wintry precipitation, okay? It's frozen. It has to be. Yeah, there may be a shallow layer of warmer air around 925 millibars lower to the surface or something that would throw a wrench in things. But overall, it's a good tool to use in general. The operational run, this is a run we look at on a daily basis, like I told you, compared to the ensemble mean. You see all these squiggly little lines here? These squiggly little lines are 51 different members, 51 different engines of this model running different variations, trying to figure out exactly what's going to happen. Then you get an ensemble mean, the average, okay, statistical average of the 51 different runs, okay? And you see the ensemble mean for a storm coming in on the 4th or 5th of February at 4 to 5,000 feet says we're going to be below freezing. It says we're cold enough for all snow in central Indiana, both operational and ensemble means. Are there still some ensemble members going above that, getting it warmer? There is, and that's always the possibility. Now, when we talk about that, here's a spaghetti plot of 500 millibar heights. Okay, notice how everything is very much in line 24 hours out. Okay, what I want you to note here is the green is climatology. All right, it's where you're supposed to be, climo. All right, so this is where these heights and these different patterns within the upper levels of the atmosphere are supposed to be displaced. Now, when we get out into the extended period, all right, let's take it out to 8 days. Notice how the spaghetti plots start to become more widespread and a little bit more uncertain. Okay, but here's one thing I want you to see within the modeling. Okay. This is actually a pretty impressive amount of consistency within the 500 millibar heights here. Okay, this is basically the polar front jet, if you will. This is saying, okay, by hour, let's go to 168 when that storm's going to come through, or 156. Okay, this is basically saying, here comes the colder air coming down with it, a storm associated with it as well. The subtropical jet stream here, or the southern branch of the jet, where some of the moisture is coming into play, is actually a little bit further north than what it's supposed to be as well. But we have 51 different computer models taking this storm over a course of where we need it to go in order to produce some type of major winter weather event. Okay, 51 different models. Now get out here to hour 360, out 2 weeks, and it's a toss. It's a coin toss. You see how the spaghetti plots just expand, and you know, there's all kinds of different possibilities and all this stuff. So, you know, what makes it right for the modeling to be right 2 weeks out on one storm, but it's not right 2 weeks out on another storm? Who determines that? Who's the police that says, oh, this model runs right because, you know, of this? Well, that's fine. There's all kinds of different ways to check to see if a model runs right. You look at current conditions. You look at observations. You look and see how the model's comparing to actual radar scans. You look and see, look at verification and see what the model predicted in Oklahoma. What did it do in Oklahoma? What did it predict in Illinois? What did it do in Illinois? You know, you look at all those different things and you decide which piece of data do you want to use. You've got all kinds of different models, all kinds of different ensembles. You've got a decision to make as a forecaster. Do you take the Moss numbers? Okay, do you take these numbers right here? In fact, I'll pull them up and say, okay, well, I'm tired today. I'm going to make my extended forecast. I'm not going to look at 850 millibar temperatures. I'm not going to look at surface pressure. I'm not going to look at thickness calculations. I'm not going to roll up my sleeves and actually do anything. I'm just going to do this, and this is right, and your forecast is wrong. Well, that's fine. But there's all kinds of different ways to forecast, okay? You can actually look at an 850 millibar temperature can actually be converted into a surface temperature. There's actually a conversion for that, and it works, okay? And you can you can pair that with thickness calculations. You can say a 540 thickness on a perfect day in the springtime under sunny skies is going to be 61 degrees or 60 degrees. You can say a 540 thickness in the wintertime at night could be as cold as 20 degrees. It could, it just depends. You have to know these things, and you have to be able to play all that out in your head. Okay, so the bottom line is guys, we look at all different kinds of data. Here's the raw data from the overnight run of the Europeans. It suggests 9 inches of snow next week. Yesterday it suggested 13 inches of snow. Right now the ensemble mean says we'll get 11 inches of snow. The other day the ensemble mean was saying, I'll show you what the ensemble mean was saying. Here's the European EPS control over the next 2 weeks, had over 30 inches of snow here. Yes, the stuff's going to differentiate, but notice the overall trend here. I'm going to end it soon because I'm rambling here, but notice the overall trend is there is a storm coming that's going to go across the central portion of the country because every model is showing it. Every major global model is showing it. Will it be Chicago, Indianapolis, Cincinnati, Lexington? We don't know, but someone is going to get a lot of snow. And major cities are going to get a lot of snow. You have a combination of a negative PNA and a positive NAO. You're going to get a cross-country cutting snowstorm that's not going to get jammed up on the East Coast. It's not going to be a nor'easter, but it's going to be a storm that's going to put snow down for a lot of major cities, and a lot of cities are going to get in on the snow. Okay? That's the point is I want you to understand that when I talk about issuing a model guidance forecast, there's all kinds of different outcomes. And guys, we just have to be able to differentiate those and understand that the way I do things is I show my fans what I'm seeing. And that's the way I will always do it. I will never change it. If you don't like it, you don't have to follow me. You don't have to subscribe to my page. I don't care. But bamchase.net will not participate in any of the rude comments or the bashing people, throwing people under the bus. They just won't be tolerated. And that's the end of that, okay? So I wanted to give you guys just a brief rundown. I could talk about this for hours and hours and get into some real deep meteorology with this, but I just wanted to kind of give you a brief rundown of what it is that we do. So hopefully you guys have a little bit better understanding of why I posted that Canadian model image the other day. And guys, it's just guidance. It tells us there's a lot of energy and there's a potential very big storm coming. If Indianapolis gets a foot of snow, that's very rare. It's not every day Indianapolis gets a foot of snow. I mean, my gosh, the city shut down the other day because it was cold, right? I mean, because we had negative 30-degree wind chills and they shut down the city of Indianapolis. So when you get a foot of snow in cold weather, it's not every day that happens. That's a major snowstorm, okay? The most single day, I think the record for the most snow in 3 days is like 16 inches in 3 days. So you got to keep in mind, this is, whenever you're forecasting a foot of snow, it's a big storm. So thanks for taking the time to listen, guys, and I'm glad that those of you who support and follow us do. All we want to do is work together and be a team player here in the weather community. And again, we will not participate in any of the stuff that's just not right. So you guys have a great day, and all the subscribers and stuff, I'll have a video update this evening on what we're looking at. Have a good day.